Network programmability basics, and it is the basics. And what we're really talking about here is software-defined networking. When we talk about software-defined networking, in the Cisco sense, we're kind of talking about centralized management and being able to send the configurations, manage the configurations centrally, a number of things. Got some images here that I hope will help, but network programmability, and nothing magical here. The use of software to manage network configuration and operation. That's something that we've been doing, want to do, have tried to do for a long time. Supports dynamic network infrastructure configurations in such a way that a device static configurations are not required. What that means is that we're going to centrally change everything, dynamically change it on the fly arrangement. Uses software to manage deployment, maintenance, and troubleshooting devices. Software tools include APIs that enable communication with devices together and set configurations. So we're going to see what's there, and then we're going to set the configurations. Some cases we're not even going to put the configuration on or not store it on the device. We're going to put in memory and make the changes and store the configuration someplace else. And I probably told you about the San Francisco network administrator who got into a difference of opinion with the mayor, basically, the people that run the city, and he wound up losing. He wound up in jail because he wouldn't give them the passwords. What he had configured was the devices that didn't have the iOSs on the devices, didn't have the configurations on the devices, because if you go back to ICND1, we did the password recovery lab, where all you had to do was control break, tell it not to load the startup config, and then you could change the password. But that meant that the password had to be there. He finally gave them to him. They let him out of jail, but he went to jail for like, I don't know, 2 or 3 months, several months. Use the network programmability features, simplifies administration, makes it easier to modify network infrastructure, and it does make it easier to modify the infrastructure. Called SDN, software-defined networking, and then here we are with one that we've seen before. Kind of tried to show you that one, the APIC Enterprise model, which can manage things. OpenSDN controller and OpenFlow, and these are open source, and Cisco has an open version and a proprietary version of it. And then the Cisco application-centric infrastructure and Opflex. So a number of different tools. We kind of looked and hopefully have a little bit of an idea about the APIC Enterprise module in this thing. So this is one, what is SDN? And this is from the SDN Enterprise, or the project itself. And it is the physical separation of the network control plane and forwarding plane, where the control plane controls several devices. We're going to look at those planes, so maybe that's going to make a little bit more sense to you. But we have 3 planes: the data plane, the control plane, and the management plane. The management plane is where we are, where we send the commands to the control plane, and then the control plane controls the data plane. The control plane would be maybe like where the routing protocols run, and the data plane would be maybe where the switching tables are themselves. Can be categorized in these things. Separation of network into operation of 3 planes enables the administrators to program and manage operations in either of these things. So a different end, I got a couple of images about this, but the management plane over here, Secure Shell, Telnet, SNMP, remote monitor, are things that would be there. And in the control plane, the layer 3 protocols, OSPF, BGP, GLBP, HSRP, some of this EIGRP, some of the stuff that we've done. The layer 2 things that would be there would be SDP. UDLD is a unidirectional link detector, which is kind of designed for fiber, so that if one side, we have two fibers and then an out, so if one side goes down, we get a warning as to what's going on. And then in the data plane, the layer 3 of the forwarding information base adjacency table would be there. Layer 2, the STP states MAC address table would be in the data plane. The storage was not part of this course, but you can see what would be in the storage elements too. But how we use the control SSH, these are the things that we connect with, and then we create these things, and then they create the forwarding table where the work is actually done in these. Different image, but kind of the thing. Configuration, management plane configuration, the control line interface, the GUI interface, and then at the control plane with static routes, OSPF, the neighbor table, link state database, IP routing table, and down at the data plane, the switching where the work actually gets done, we have the forwarding table. And what we're going to do is to separate these things and take the configuration information off of the device and run it centrally. Data plane, and hopefully we've already got a little bit about it. The data plane, a collection of tasks performed by a networking device where it handles data. Includes the operations performed by a device when it receives, processes, and transmits data. Data is frames, packets, messages, the things that I think we would expect to be there. Perform several actions. One of the most important tasks of a router or a switch in the data plane is the forwarding of data. The switching table is in there. The switching table, when we talk about that, when a packet comes into a router, it gets switched from one interface. If it's supposed to go out down here, it gets switched to this interface so that it goes through the router and out the interface that it's switched to. So the platform data actions, routers and switches, add and remove the .1Q headers, VLAN trunks. D encapsulates and then encapsulates packets into frames or routers and layer 3 switches if we're doing that. This is if we have something that comes in maybe from a PPP, from a serial link, and then goes to an Ethernet. If we do that, we have to take the PPP encapsulation out and add the Ethernet, encapsulate them into Ethernet frames, one to the other. So routers actually do a lot of different things. Layer 3 switches match IP addresses of destinations in the routing table. Layer 2 switches the MAC addresses, access control lists, filter and drop messages, NAT, translate the IP address, and then the VPN is going to encrypt the data and add the IP headers for the VPN processor. So the data plane is where the work actually gets done. Another kind of image here, the control plane, actions that controls the data plane, which is kind of using it in itself, but it's got the instructions. It's got the protocols running on it, and it sends the information that we need to do the work. So the control plane, OSPF, would be here, and it would send the forwarding tables to the data plane so that they would know which interfaces to send the information out of. Requires the functions such as routes, MAC address entries. So the MAC table is there. It sends the MAC addresses to the data plane. Creating and managing the routing tables, operations for creating and managing MAC address tables, ARP tables, OSPF, routing protocol manages routing tables, which OSPF we've done, and hopefully you will do or have done the OSPF labs. On each it uses the and the EIGRP labs. Tables to the forwarding, protocols and network devices function to help separate the data plane and the control plane Control plane enables the data plane to work efficiently. It provides the information. It's kind of like IT. I talked about that IT doesn't really make anything, but provides efficiencies. The management plane enables management of networking devices. Protocols that we saw earlier, SSH, SNMP, Syslog, Telnet, are protocols that are available there for management. So we have the management plane, Telnet, connect to, send the information to the control plane, and the control plane then provides the efficiencies for the data plane, or the resources for the data plane to send its information. Protocols are not essential for the working of the network devices, but they are essential for communicating with the network devices. SNMP and Syslog help troubleshoot and diagnose problems, perform maintenance tasks. We've talked about them before earlier. Controller, now we're getting into the device that we're going to use. And this here we have the APIC, and this is the ACI, the APIC ACI, but the remote controller, which is going to manage all of this information. Centralized application performs all or some of the actions of the control plane, usually runs on a server. So we're going to connect to this. We'd have the management goes in here. This becomes the control plane. So all of that information out of the control plane is going to be in this server. The extent of the control plane is handled by it varies. Is configured to handle all the control plane actions. Centralized manner. Controller set up such a way that it's reachable by all devices, and are configured with data planes only. The devices are only have data planes. The control plane, none of that stuff's going to run on the devices anymore. It's going to be centrally managed. They don't have control planes, so they don't have the protocols. The protocols are going to be running on the controller. The routing MAC address ARP tables are created and updated by the controller, and then that information is provided to the data plane so that it can perform its responsibilities. The network devices only use the entries from these tables, and that's one of the ones to me it gets a little bit, okay, what's the difference? So we're creating them at the control plane, and we're going to use them at the data plane. The differences between traditional and an SDN, a traditional network, the dynamics, highly complex in a multi-device mobile environment, and it does. As we get more and more devices, it becomes harder and harder and harder to manage. Software-defined, quickly adapts, and this obviously is an advertisement for these things, to business needs. Policies, network-wide policy changes need to be device by device. This is one of the big advantages. We can centrally manage the policies here. Scaling, at some point it does become unsustainable due to the complexity and just the amount of management that we have to do, routine maintenance that we have to do. Scalable because we can add devices easily to this thing. Device control, let's say incomplete because the changes are subject to vendors' product cycles. Oh, so true. The software-defined network, and this is from ypro.com, is vendor agnostic control, can lie anywhere in the enterprise. So downside, upside, the downside obviously it's going to cost. Another image to try to, what do these things do? A traditional switch has the control plane and the data plane on it. The software-defined network has the controller machine that has the control plane separate from the data plane on the switch. Now, can you just go in and take a 2600 switch and make this work? No, you got to have something that is compatible with it, like everything else that we talk about. It's got to be compatible. We talk about northbound and southbound interfaces, and this is the SDN controller platform. The southbound interface is where the devices are, and the northbound interface is going to be where the applications, where the management information is. And the reason they named them this way is because in images or in diagrams, we usually draw the devices on the bottom and the control stuff on the top. So they made the southbound and northbound interfaces do that. Southbound interface, an API enables exchange of data between a controller and another program running on a network device. As an interface that enables communication between a controller and a network device. Southbound interface configured with protocols and the southbound API required to establish communications between a controller and the network device. Uses the southbound interface to pass routing tables, MAC address tables, so it's going to use the southbound interface to send all of the information that the data plane needs to use to do its job. The northbound interface controller stores several pieces of information, such as a list of all devices in the network, the topology, the interfaces for each of the devices, IP addresses, VLANs, the device capabilities, current state of the devices, up, down. Northbound interface enables a program or an application to obtain information stored in the controller and process that information. Northbound API enables the exchange of data between the controller and the application. By using the information from the controller or the app programs, the logic controller maintains the forwarding tables in the network. So I guess the brains of it is going to be here at the northbound interface, where we actually do things, not work. The enterprise architecture, the data plane has the network devices, routers, switches to get the message. The controller handles the functions of the control plane, and the SBIs enable communication between the controller and the network devices, while NBIs enable communication between the controller and the application. So we have the whole process broken down into multiple planes, and we're controlling it off of the network. And again, really short, and it is an overview of what goes on with the software-defined network, or software managed network, software-defined network. The use of software to manage the configurations called network programmability. Software-defined network operations of the device is categorized in three planes. We had the management plane, the control plane, the data plane, and each of them had a different function. The data plane is where the work is done. Control plane, the actions that controls the data plane, actually the actions that provide the information that the data plane needs to do its job. And then the management plane are protocols that enables management of the network devices themselves. And then we had the controller, which was the centralized device to do all of this work. Southbound interfaces and northbound interfaces. Southbound communicate between the controller and the network device. The northbound exchange between the controller and an application, so that the information to a controller logic goes on here. So northbound, southbound, three different planes in order to do these things.